All right, this is a video for this last problem in the AP related rates and implicit practice. And I think some parts of this one are pretty difficult. So first off, we have this curve, which we cannot easily solve for y. So for part A, we have to show that dy dx equals this expression. That means we have to differentiate with respect to x on both sides. And we will use implicit differentiation because we can't just get this equation to be y equals something. So there will be lots of chain rule happening on this one. So anytime I have a term with y, I need to make sure I chain rule and include a multiplier of dy dx. So the derivative of 2y to the third is 6y squared dy dx. This derivative, be careful here, you need product rule. It's easy to accidentally, as you're going through this, just be like, oh, that's 12x times dy dx, but that's not right. You have product rule. This is the first function. This is the second. So I'm going to say first times derivative of the second. Derivative of y is 1 dy dx plus second times derivative of the first. So that is product rule for that. And then the derivative of minus 12x squared is minus 24x plus 6 dy dx. On the other side of the equation, the derivative of any constant is equal to 0. And then you can't just write dy dx equals this answer. You're supposed to show that that's true. So let's go ahead and show ourselves factoring out dy dx. You could also reduce the equation by 6 right now. I'm just going to do that later. Doesn't matter when you do it. But if I factor this out, I get 6y squared plus 6x squared plus 6. I'm also going to move terms, the non-dy dx terms, to the other side. So plus 24x minus, this could be 12xy. And now I can divide by the parentheses. I'm also going to show that I'm factoring a 6 out. Or again, you could say divide both sides by 6. I'm just going to factor a 6 out. This will give me a chance to, I want to check the final answer. Make sure I have all my terms in the same order as they do. So see here, I switched it up. I had y squared first and then x squared. So I'm just going to show that this is 6 times x squared plus y squared plus 1. Don't just cancel those and leave it at that. It's always a good idea to have your final line be exactly what they want you to show. So this is my final, it's kind of like an algebraic proof. You're just showing the steps to get there. Okay, part B. Write an equation of each horizontal tangent line to the curve. So what does horizontal tangent line mean? It means dy dx needs to equal 0. And what does that mean? Remember, they gave you dy dx. So even if you totally kind of screwed up on part A, they give you this formula, so you can still do part B. That means that I'm setting the top equal to 0. So 4x minus 2xy would equal 0. To solve this, I can factor out a greatest common factor of 2x. That would leave me with 2 minus y. So we get two solutions. One is in terms of x equals 0, and one is in terms of y. And what is the question that we're supposed to be doing? Writing an equation for each horizontal tangent line to the curve. So to write an equation, you need a point and a slope. And we know the slope is 0. So like y equals 2 is a horizontal tangent line. So we know that that's true. For the x value, this is not the equation of a tangent line. I need to go back to the curve and plug in 0 for x and see what's left for the y coordinate, because I don't know I don't know what the y coordinate is. I'm trying to come up with a point. So this is already a horizontal line. So I can stop there. I don't need a point slope formula. I can just say that's that. But this one, I need to say, so it's 2y to the third plus 6. If I put in 0 there, I'm going to get 0. 2y to the third plus 0 minus 0 plus 6y will equal 1. So 2y to the third plus 6y equals 1. Now this is not something I can factor, and it doesn't just turn out to be a nice fraction, like a nice rational answer. So I do need to use my calculator to solve this. Whether you're using the graphing calculator or Desmos, I haven't found a way that you could just type in 2y cubed plus 6y and find out where it intersects a value of 1. So when I go to Desmos, split screen here, I am going to type this in as f of x. And I could do like minus 1 equals 0, or I could find the intersection point. But I'm going to do like f of x equals 2x to the third plus 6x, and then y equals 1. And I'm just looking for their point of intersection. I'm going to zoom it in so I don't accidentally grab that point. So this is y is approximately, I'm going to keep the whole point in case we're doing something with this. Otherwise, I could round to 3. So that is the other horizontal tangent line. It's not like AP Pre-Calculus where they're going to say this is wrong because you didn't round to 3. Round to at least 3 decimal places, I would say. I'm just going to leave it like that. All right, and part C. I think part C is kind of tricky. On problems where you read it and you're like, what? Try to write down something that you know about the problem. So this says the line through the origin with a slope of -1 is tangent to the curve at point P. Find the x and y coordinates of point P. So we have some sort of curve. I don't really know what it looks like. Let's see. Let's say this is our y equals -x, our slope with -1. This is our tangent line. We're trying to figure out what is that point. So first off, I can write the equation for a line through the origin with a slope of -1. That's just y equals -x. And then what do I do with that? So if this is y equals -x, I'm trying to come up with point P. So I can say in the equation, I don't want to do anything with dy dx because I already know the slope of this tangent line is -1. When I'm trying to figure out the point, I can use substitution here to solve for either x or y. I think it would be easier because this is y equals -x. I think it would be easier to go ahead and instead of having 2y cubed, plug in the -x to the third. And let's see. Oh, I have the equation right here, so I don't keep scrolling. So plus 6x squared instead of times y times -x. So I'm plugging this in to the original curve so that I can try to figure out what's the x coordinate. And then once I know the x, I will know the y because y is -x. Minus 12x squared plus 6 times y, but instead of y, -x. And remember, this is equal to 1. So let's clean this up a bit. This is coming out to, this will be -2x to the third minus 6x to the third minus 12x to the second minus 6x equals 1. So this is -8x to the third minus 12x squared minus 6x equals 1. And again, I can use a calculator on this problem. So I am going to go back to Desmos here. You have 2 options here. You can subtract 1 and look for the zeros on this function, or I already have y equals 1, so I'm just going to type in like f of x equals -8x to the third minus 12x squared minus 6x. And I'm looking for where these two intersect. And it's a nice point, -1/2. Right. So that was my answer for x. So x is equal to -1/2. And remember, y is just equal to -x. So y is equal to +1/2. Remember to answer the final question. What is point P? Point P is -1/2 positive 1/2. So kind of a tricky question. Again, if you're not sure where to start, write something down. It could be that on the scoring guidelines, you get a point just for writing like y equals negative x, like knowing that that's something you're supposed to work with. So, we don't want to leave anything blank. We want to at least write the first step. For part B, at least write dy dx equals 0. Sometimes even just writing that will get you a point, and it can trigger your brain into maybe a possible next step.